Welcome back. Welcome back to Hudson Valley Statistics 220. Today we are going to discuss Chapter 17 in your textbook, which is the chi-square. Chi-square it's pronounced chi, but it's spelled C-H-I. And the chi-square is used for frequency data. Now, once again, I hope you printed out your Chapter 17 handout so you can follow along with me. You're welcome to pause it anytime you want. And don't forget, you can also email me or stop by my office hours for any questions. So I'm going to move it over to the handout. And this is Chapter 17 handout, as you can see. And this is pronounced chi. And where we apply the chi-square distribution is in frequency data. Okay? Now, frequency data is counting maybe the number of people that have green, blue, and brown eyes. As you can see, it is not a normal distribution. It's skewed. It's always skewed to the right. It stops at 0, but it goes on forever, and the degrees of freedom affect the shape of the curve. We are actually going to use the 5-step hypothesis testing procedure for the chi-square. If you look down to the center of your handout, there's hypothesis testing, and you are going to let FO and FE be the observed and expected frequencies respectively. Very important. FO is from your sample data. It's always given. F sub E, and I am going to discuss two different types of frequency data. F sub E will always be calculated. And the formulas for calculating FE should be on your 3-page formula sheet. So you might want to pause this video and pull that out. There's two formulas. For equal frequency, equal expected frequency, the formula is total observations or sample size divided by the number of categories, K. That's going to be our first problem, and that's calculating expected frequency. When we have unequal frequencies, you will calculate F sub E by the percent times the total observations. Okay? Both those formulas are on your 3-page formula sheet. Okay. Null and alternate hypothesis. You are welcome to copy it down directly from the formula sheet. There is no difference between observed and expected frequency. There is a difference between observed and expected frequency. Null and alternate. Okay? Alpha is given in the problem. Because we're dealing with frequency data, it will be a chi-square, and I'll talk about the formula in a bit. To find the critical value, you need two things. You need degrees of freedom, which is K minus 1, the number of categories minus 1, and the theta to find your critical value. And then I'm going to show you step 5 on the calculation. So let's go to our first example. If you turn the page, this is the chi-square formula. Chi-square looks like a italics x squared. Observed and expected. Remember, this symbol is summation. So here's our example. I'm going to give you a minute to pause this and read our example. Okay, you're back. A marketing manager wants to produce baseball cards of these 6 players. She doesn't know how many cards to produce on a mass production basis. Should she produce 10,000 of each, 5,000 of each, or maybe they're not, maybe 0 of Johnny Bench and 10,000 of Tom Seaver. She doesn't know that. I'm going to read the last question in this paragraph, and we will determine, that will determine how to perform this hypothesis testing. Can she conclude the sales are not the same for each player? Use 0.05 significance level. Okay, not the same, or the same, equal or not equal. She's wondering, are these players equally popular? So she should produce 5,000, 5,000, 5,000, 5,000, 5,000 on a mass production. Or maybe they're not equal, and maybe we, like I said, we shouldn't produce any of Johnny Bench. So we're going to perform the 5-step hypothesis testing to determine that. Our first step, the null and alternate, of course. Again, as I mentioned, you literally write down what I have on the formula sheet. There is no difference between observed and expected. There is a difference between observed and expected frequency. Alpha, right from the question, 0.05. Again, step 3, you find the critical values and what formula should you use. The formula is ChiSquare sum observed minus expected squared over expected. Let's look at the degrees of freedom. There are 1, 2, 3, 4, 5, 6 categories, minus 1 or 5 degrees of freedom. At the alpha, 0.05. So we look up in our chi-square. Here's our chi-square. I label it chi-square up here. So on this example, we have 5 degrees of freedom, and we go all the way over to 0.05 as our alpha, and we have a critical value of 11.071. So our critical value is 11.071. So in other words, now we're drawing a skewed distribution, critical value, or 11.070. This is our do not reject our null hypothesis, and this is our reject our null hypothesis. So after we do, after we do a calculation, if we get anything less than 11.07, we do not reject. If we get anything greater than 11.07, we do reject our null hypothesis. Now this is just a bit of information because we're coming close to finals. I want you to remember that the null hypothesis is always a statement regarding the population, whether we're talking about frequency data, whether we're talking about mean data, whether we're talking about proportion data. It's always a statement about the population. We are trying to determine if the population are equal here for each baseball card. So, just something for the next test or the final exam to remember. Okay, now we're going to continue on this. We've done step 1 through 4. Now comes step 5. you move on to your handout, okay, F sub 0, again, our observed frequencies, they're given. They're from our sample. Our observed, we want to calculate. This is an equal frequency question. So to calculate our expected frequency, we add up our baseball cards we sold, which was 120. If we add up all the baseball cards we sold, divided by the number of categories, in this case it's 6. So our observed frequencies will all be 20. I tell students that, you know what, a way to think of this, in a perfect world, if I went out there and I had all these players were equally popular, I would expect in a perfect world to sell 20 baseball cards, 20 baseball, 20, 20, 20, and 20. But that's not the case here. This is actually what I sold. So I want to determine if these differences are statistically different. If they are, we're going to reject the null hypothesis. Or by my calculation, statistically speaking, they're the same numbers. They came from the same population. If that's the case, I do not reject my null hypothesis. So how do we do the calculation? Well, if you look at the formula, and I'm going to talk to you a couple of different ways. We are going to subtract the observed minus the expected and square it. Divide that number by expected. So in this case, in this first one, and I'm going to put it right there, and I'm going to do it big so you can see it. Observe 13 minus expected 20. Square it and divide it by 20. So that would be -7 squared divided by 20, and that comes out to 2.45. So this first line item is 2.45. I'm just going to do a couple of here, and then I want you to pause it and do a couple. The next one would be 33 minus 20 squared over 20. When you do that calculation, you get 8.45. 8.45. So I want you to do the next four. For 14 minus 20 squared, 7 minus 20, 36 minus 20, and 17. And calculate, it's actually the chi for each of them. And you can pause it. Now that you're back, I'll give you the answers. It's 1.8, 8.45 again, 12.8, and 0.4. This, if you can't read this, it is in my PowerPoints. When you add up these numbers, you get 34.4. That is my calculated chi. If I graph it on my chi distribution, 34, you'll see our conclusion will be to reject the null hypothesis. Reject this, and now we can say there is a difference between observed and expected. So these are not equal. There is a difference. There is a difference between observed and expected. So these baseball players are not equally popular. That is an equal frequency. Okay? The next problem we're going to do is a chi-square with unequal frequencies. Okay? Chi-square with unequal frequencies. How do we know the difference? Well, we are still given the observed frequencies from the sample. However, in this example, we are going to be given percentages, 40%, 30%, 20%, and 10%. So when you start to draw your table, you probably, here's your observed from the problem. Give you a minute to read the problem. These are observed. But you want to add another column in here, which is the percents. And you get the percents from the problem, and it said 40% visit the hospital 0 times. 30% from national data visit the hospital once. 20% and 10%. Okay? This information is from your question. Okay? So let's go back to our 5-step hypothesis procedure. Null and alternate. Again, there is a difference between FO and FE. There is not a difference between FO and FE. In this case from the problem, our alpha is 0.5. It's a chi-square, so our formula is FO minus FE squared over FE. Degrees of freedom, again, it's the number of categories minus 1. In this case, we had 4 categories minus 1, or 3. So let's look up 3 and an alpha of 0.05 to get our critical value. Three and 0.05. Come down here, degrees of freedom, 3, 0.05, 7.815. This is our do not reject our null hypothesis and our reject our null hypothesis area. Now we get to do the calculation on the next page. Okay, back to our calculation. Okay, this is our observed, our given from our sample. We were given percentages from the National Association of Hospital Administrators Association. We have to calculate our expected. How do we calculate expected? We take our percentage times total sample size. Okay? For each of them. In this case, it's 60. 30% times 150 is 45. 20% times 150 is 30. 10% times 150 is 15. These are our expected, so we write them right here, 60, 45, 30, and 15. Now everything else is the same. Just like the first, second, and third step are all the same, fourth step too. Once we get our expected, we calculate our chi for each one of these categories. The first one, observed 55 minus expected squared divided by expected. That's 0.42. Next one, 50 minus 45 squared divided by 45. Oh, 45, right. And that's 0.56. I'm going to want you to pause, and I want you to calculate the other two. Okay, you're back. The other two are 0.13 and 0.27. You add up these, and you get a calculated chi of 1.37 approximately. 1.37. We plot it here. Oops. Wrong distribution. 1.37. 1.37. Our conclusion is do not reject null hypothesis. Okay? I want to double check. I want you to go back here. There is not a difference. I forgot not. And this one, there is a difference. I apologize. Very different here. There is not a difference. FO and FE are equal. That's what our conclusion is. Our alternate should have been there is a difference between FO and FE. That should be the exact same as the other one. I apologize for that. But what does that mean? It means, see these differences? They are not statistically the same. These differences are not statistically the same. Okay? So that concludes this chapter. I apologize for that mistake in stating the null and alternate, but that is chapter 17. The end of chapter 17. Thank you. And if I've added to confusion, please come and see me.